Alright, we're going to carry out a second example of stoichiometry and conversions. This time, we're going to start with 15.0 mLs of 0.123 molar concentration KClO3. And we want to find out what the mole fraction of KCl is going to be, assuming that the final solution ends up being 50 mLs in volume and it has a density of 1.15 grams per ml. These values are not necessarily based on reality, but we're going to use them to carry out the calculation just to show you how this works out. All right, first things first, we gotta recognize that we're starting with molarity for the reactant, KClO3. So this is our starting point. And from molarity, we can go to moles of the solute using the volume of the solution. Specifically, you want to have the volume of the solution in liters. So we're going to take the 15 mLs of solution, we're going to divide them by 1,000 to get the liters of solution. mLs cancel out, and now we have 0.0150 liters of solution. Now, the way you go from molarity to moles is to simply account for the fact that molarity is nothing more than moles over liters. So if you do have liters as volume, you just make sure that in your fraction you end up with liters on the bottom and moles on the opposite end. And since molarity is moles per liter, the 0.123 has to go with the first unit, aka the moles. So we have 0.123 moles of KClO3 divided by 1 liter of solution. That's the same thing as 0.123 molar. This allows us to enter the realm of moles for KClO3. And now that we're in moles, we can make the switch over from KClO3 to KCl. And for this, we use the balancing coefficients in the balanced equation. All right, so now we're basically at this point, we're going to do the switch over for moles. All right, so we have 2 moles of KClO3 for every 2 moles of KCl. That is the conversion factor we're using here to do the switch over. All right, now this is going to give us the moles of KCl. And I would recommend that at this point you do get the moles of KCl. Now, alternatively, you could solve this problem by setting up a Sudoku table. Mudoku table. I'm getting ahead of myself here. But you're going to have to keep in mind that you have 2 substances for which you're applying this. So I would recommend that you don't do the Mudoku table until you've gotten to the moles of KCl, because it's that substance for which you're trying to find the unknown concentration. So find information about the solute, which is KCl, maybe the solution, and perhaps the solvent, which will be water. And since we're on topic, one thing to keep in mind is that anything that is on the equation, whether it's a product or whether it's a reactant, as long as it's not water, anything in the equation is considered a solute. And yes, you can have more than one solute present in the same solution. We've kept it semi-simple for the most part in the class up until this point, but the truth of the matter is that any of these molecules, KClO3, KCl, and O2, if they are in solution, they are all considered solutes, and water will be the solvent. All right, so going back to this Mudoku explanation, right? Once you find the moles of KCl, the thing for which you're trying to find the concentration, here you can set up a Mudoku table, and it might actually be easier for you to do that. But I'm going to show you a different way of approaching the same problem just to give you options. Now, ultimately, what needs to happen to find the mole fraction is that we do need to know the moles of the solution. Moles of solute divided by moles of solution gives us the mole fraction. So we need to basically find a way of finding the moles of solution. And based on the data that we have right now, we do have the volume of solution, nothing else. Now, once again, this can be done with the Mudoku table, so it doesn't have to be done the way I'm presenting it right now. I'm just giving you a different perspective of how you can solve the problem, just to give you options. All right, so from the volume of solution, we can switch, and really the only place we can go is to the mass of solution. in order to do that, we need to use the density of the solution, which we have also been given as of now. So we're going to do that. We have the 50 mLs of solution, and we know that the density is 1.15 grams per ml. The number always has to go with the first unit that appears. So the 1.15 goes with the grams. The mLs will be by itself with a 1 as the placeholder. Since you have mLs on top over here, you want to place mLs on the bottom of the fraction. The 1.15 grams will go on top, and this will cancel out the mLs, and it will give you the mass of the solution. You probably want to write down this number, input it into your Mudoku table if you have one. Alright, now what we do have right now is the mass of the solution. We need to find out the mass of the solvent so that we can figure out the moles of solvent. We do have the moles of the solute, but we don't have the moles of solution. In order to get that, we need to get the moles of solvent. So we're going to subtract the mass of the solute from the mass of the solution. And speaking of which, as of now, we only have the moles of solute, so we're going to convert the moles of solute to mass of solute using the molar mass of KCl. Moles go on the bottom to cancel out units, grams go on top. And multiplied together, this will give you 0.137 grams of KCl. Alright, now we do subtract the mass of the solute from the mass of the solution to get the mass of the solvent. Okay, this will be everything that you will be putting into your Mudoku table. It might be better to do it that way, but once again, you could do it this way without any repercussions. Alright, so subtracting the mass of the solute from the solution, we get the mass of the solvent, and in the absence of any information, the solvent is assumed to be water. So we can now convert the mass of the solvent to the moles of the solvent using the molar mass of water. 18.2 grams on the bottom to cancel out the units, 1 mole on top. Okay, so the grams cancel out. And upon carrying out the subtraction followed by the division, we should end up with 3.18 moles of water. Alright, so we're almost there. Now that we have the moles of the solvent and the moles of the solute, all we need to do is add them together to get the moles of the solution. And once we add together the moles of the solvent and the moles of the solute, we get the moles of the solution. To get the mole fraction, divide the moles of the solute by the moles of the solution, and this will give you a unitless number that is less than 1. In this case, we're talking about 5.78 times 10 to the negative 4. Alright, that concludes this specific example.